Hello everyone and welcome. In this video I'm going to talk about hash tables. So a hash table is basically an array that has a hash function. How does this work? Well, we're going to have here an array, like I said, that's going to have different indexes, and this is going to be our hash table. Now, if you want to insert an element in this hash table, all you need to do is get a key that's going to represent the element that you want to insert, apply a hash function to that key, and that hash function is going to map to an index of the array where you're going to put that element. So for example, if your key is a string, for example, a name, you apply a hash function to it that turns it into a number, which is going to be the index of our table, and then you put the element in that index. So that is how a hash table works. Now, obviously, this is a great advancement in relation to arrays and linked lists, because any operation that you want to perform, whether it is inserting, searching, or deleting elements from the hash table, can be done in constant time or really close to constant time. So O of 1, right? Now, this hash function needs to be computationally light, so it doesn't really matter if you have a hash table if then the hash function is not fast and it is really computationally dense and you need to waste a lot of time to apply it, because then it really defeats the purpose of a hash table, which is speeding up the process of searching and inserting elements. The second thing is it should always produce the same output. It doesn't matter if you have a super fast hash function, if then each time you calculate it, it gives you a different index of the array. And the third thing is you want it to be pretty random, right? You want the values to be spread out throughout the table, and you don't want different values or different keys to map to the same location, because then you're going to have collisions, and dealing with that is not the best. Now, keep in mind that a hash table also has disadvantages, right? It doesn't support operations like sorting, and you're probably going to have to allocate more memory than necessary. So you're going to waste a lot of memory as well. Now let's actually get into some code. Enough with the theory, because I know that's what you really want to see. All right, so let's do this. My hash table is going to be made up of structs. I'm going to name this car, and each car is going to have a license plate, which is going to be a string. As of now, that's all I'm going to put in here, but I am going to add something in the future. And now let's actually create here our hash table. This is going to be an array of car pointers, and the size is going to be num cars, which I haven't defined yet. And I'm going to initialize everything at null. All right, so now let's define up here num cars, like that. And this is going to be 10. All right, so now we have our hash table created. How do we actually hash each plate to a value? Well, let's actually create here a function called hash func, and this is going to take in our license plate. So string plate, like that. And we need a couple of values here. First, we need our hash value, which is going to be started at 0, and it's going to store the actual hash for our plate. And then we need the length here of our plate, so plate dot length, like so. And now I'm going to iterate through my plate. So for int I equals 0, I is smaller than the length, I plus plus. And now I'm going to say hash value plus equals int the plate at position I. So we're basically going to add each character, or the ASCII value of each character of my plate, to the hash value. And I actually don't know if you need this in function right here, but anyways. So now let's say hash value is equal to the hash value itself times the plate I, like so. Now let me actually encapsulate this in that function. It's going to be int, and we don't need the space, and we don't need the space. All right. Now in the end, let's actually return here the hash value. However, there is a slight problem with this. Let me actually illustrate that. So I'm going to create a car here called car1. Let's say car1.plate is equal to AA00 AA. Now let's say int result is equal to the hash func of car1.plate, like that. And let's see out here result, like so. So if I actually run here this code, this is going to output this huge number. Now, obviously, this is not a valid index of our table. So how do we make this huge number fall between 0 and 9, right? Which are the possible positions of our table? So that is actually really easy. All we have to do is go here and calculate the remainder of this by the number of cars. Let me actually put parentheses right there. And there you go. Now this hopefully will fall between 0 and 9, and there you go. Now we get 5, right? That is a valid index of our table. So all you need to do is really calculate the remainder of the division by 10, right? Because the remainders of the division by 10 can only be the numbers 0 through 9, right? There's no really other possibility. All right, so this is going to be our hash function. Now keep in mind that this is a very simple hash function. There are a bunch of hash functions out there. There is city hash, there is murmur hash, there is farm hash. So all of those are nice hash functions that you could explore, but this is a simple one that we'll do just for now. Now let's actually add cars to our table. Let me delete this. And I'm going to create here a void function called insert. This is going to take in here our cars hash table. And it's also going to take in a pointer to a car. So in here, the first thing is calculate the hash value of this car. So this is going to be hash func, the car plate, like that. And now let's actually insert. Well, to do that, all we need to do is the cars at the hash value, which is going to be our index, is going to be the car that we pass in, like that. And that is all we need to do to add a car to our table. So let's insert here with our cars list, and let's insert car 1. And I actually need to pass in a reference here because my function is asking for a pointer. And now let's code a function that allows us to see our cars. Let's say print table, like that. This is going to take in here our cars table, like so. And now let's iterate. For int I equals 0, I is smaller than num cars, like so, I plus plus. And now I'm going to code here something that allows us to see whether a position of the table is empty or not. So let's say if cars at index I is null, then I'm going to see out null in a string and a \n. And otherwise, I'm going to see out cars I plate, and I need to actually see out this. So let me say see out here, the cars I dot plate, and then I'm going to do the same thing with a \n. So this should probably allow us to see our table. Let's print the table with the cars. Now let me actually run this and let me pull this up to see what we get. And there we have it. Now we have here our hash table. It's going to have a null in the positions that don't have anything. And then it's going to have the car that we just added. So let's add here a couple more cars. Let me say here, let me paste that in. Let me say here car 2. Let's give it another license plate. 90 and 1P, something random. And let's print our table. All right, perfect. Now let's grab here this again and let me paste it. And now let's name this car 3 and let me see if I can do this. So B00AA, like that. And let's run this now. All right, so that did exactly what I wanted it to do, which is these cars AA00AA and BB00AA are going to map to the same location. Now, since we don't have anything that allows us to deal with collisions, when we add the second car to that index, it's just going to override the previous car that was there before, right? We don't really want that to happen. So what are a couple of solutions that we can have? Let me grab here my whiteboard and let me grab my pen. So how do we deal with this? So the first solution is something called linear probing. So imagine that we have our table right here. We have a bunch of indexes. Now imagine that this index is taken and we add another value here to this index. This is obviously going to result in a collision. So we do linear probing. We go look for an empty position. So we go to the next position. If it is not empty, we go to the next position. If it is not empty, we go to the next, and so on. And maybe this is empty, so we put our element right there. Now, this obviously is not the best way to deal with collisions, right? Because this actually defeats the purpose of a hash table, which is not having to waste time inserting and looking for elements. We don't want to look for an empty slot every time we want to add an element, right? And also, if we have our table full, we either have to reallocate a new table or we just can't add any more elements, right? So the second solution here is going to be double hashing. So we have a first hashing function, and this is going to generate a collision. And so what we do is we apply a second hashing function to determine the increment. And then this is going to give us our index. Now, this is also not the best way to do this. And so the way I'm actually going to teach you is going to be external chaining. Let me write that here. And with external chaining, each position of our table, instead of being just a pointer, is going to be a linked list. Now, if you don't know what a linked list is, I do have a video on that. It is pretty complete, and it's going to give you the beginner tools to understand this. But basically, if we have here our hash table, it has a bunch of indexes, and each position is going to be the head of a linked list. And then when you want to add an element and you have a collision, you just add that to the linked list. And then you add that to the linked list, and so on, right? So each position is going to be a linked list, and all you need to do is chain the elements together. So let's actually see how this works here in our code. So the first thing I need to do is add here in my car a next pointer. So I'm going to say car next, and this is going to contain the next element of our linked list, right? Now I need to alter here my insert function. I need to calculate the hash value in the same way, but now we're going to have a linked list in the position of the hash value. So what do we need to do? We're going to say car next is going to be cars at the hash value, like so, because the cars at hash value is going to be the head of our list, and we want to add the car. We want to basically make the new car the new head of our list, and then we have to say cars at hash value is going to be car, like so. And this is going to add our car to the beginning of our linked list, so to the head of our linked list. And now we also need to alter here the print table function. So instead of this, I'm going to say car pointer is going to be current, like so. And this is going to be the cars at the index I. And now let me say while current is different from null, I'm going to see out here current plate, and I also need here a separator so that we don't have everything smushed together. And then I'm going to say current is equal to current next, like that. And now down here I'm going to say see out a \n, like so. So let's actually see if this works now with those same plates that we had before. So if I run this now, this is going to output our table. And as you can see, in the position where we had a collision, it's going to give us a linked list. And let me do this again. So let me find here another car with collisions. I'm going to name this car 4, like so. And instead of VB, I'm going to say CC. And if I run this now, there you go. Now we had another collision, and that new car that we added is at the beginning of the list. So that is how you do external chaining. Now let's learn how to remove an element from the table using external chaining. So I'm going to go up here. I'm going to say void remove, and this is going to take in here our cars list and the plate of the car we want to remove. So the first thing, as always, is to get the hash of the plate. So let me say hash func with the plate. And then keep in mind that each position of my table is going to be a linked list. So I'm going to say car current is going to be the cars list at the hash value, like so. And this is going to be a linked list. And also I need a prev because we're going to remove, and we're just going to set this equal to current in the beginning. So now we need to iterate through our linked list. I'm going to say while current is different than no. And then we need to check if we found the car that we want. If current plate is equal to the plate that we pass in. And in here, we're going to have a couple of cases. So if our hash, if our cars at the hash value is equal to current, this means that the car that we want is at the head of our list. So we're going to basically eliminate the first element. And how do we do that? We're going to say cars at the hash value is equal to cars at the hash value next, right? And this is how you remove an element from the beginning. And otherwise, this means that the element that we want is either at the end of the list or in the middle of the list. So all we need to do is say prev next is equal to current next, like so. So we're basically going to link the previous element to the element that's after the element that we want to remove. And then the element that we want to remove is no longer going to be linked to the other elements, right? And then in the end, all we need to do is say prev equals current, and current is equal to current next, like so. And also, if we find the car that we want, I'm going to return. So we're going to terminate the function. And down here, I'm going to say cout not found. So if we haven't found the car that we want, we're going to just, print a flag to say that. Okay, so now let's actually remove here an element. So let me say remove. This is going to take in the cars list, and then it's going to take in a string. Let's say, for example, BB00 and AA. All right, and if I run this now, let's see what it outputs. And there we go. Now we have removed that car from our list. Now let's do the same thing here with this car. And if I run this now, there we go. Now we've removed that car from our list. And that is all we needed to do. Sorry, I keep saying list, but I meant hash table. Now, this is actually very similar to a search function, to how you would do a search function. I'm actually going to grab this here, and I'm going to say, instead of remove, search, like that. And this is going to this is going to return to us a car pointer, like that. And now, instead of deleting the element, I'm going to return the current, like that. So I'm basically going to return the car that we want. And down here, I'm going to return null. So this is going to find the element that we want. So let me go down here. Let me say car, and it's going to be car, and it's going to be search. And let's, for example, search for AA00AA. And let me just print here found so that we can actually see that we found it. Found. Exclamation point. And now let me run this, and let me pull this up, and it's going to say found because we found the car that we wanted, and it's going to print our table. So that is actually all I wanted to show you today. That is how you insert, delete, and search for elements in a hash table. That is how you create a hash table with pointers to structs, and that is basically it. So thank you so much for watching. I hope this video was helpful. If it was, please like and subscribe to support the channel. Thank you so much, and I'll see you in the next one.